ODL system. There are 3 elective courses. The learners can choose any one course from 3 elective courses. Each course is of 4 credits. Now coming on to the job prospects. The job prospects can be widespread. It can help in teaching and research, cartography, mapping, urban and regional planning, population and demographic studies, natural resource management, environmental management and sustainability, geospatial analysis, GIS and remote sensing, tourism and recreational industries, administration and marketing, disaster management, transportation and logistic industries. So what are you waiting for? Go to the Samarth portal of IGNOU and take admissions as soon as possible. Alternatively, you can type on Google IGNOU admissions and you will be redirected to the Samarth portal of IGNOU and go and register there and take admissions as soon as possible. In case of any query, you can write to us at satyaraj@ignou.ac.in.
Hello learners, welcome to this session. This particular course BEY-020, BCS-011 or BCS-111. Actually this is the first computer science course for BSc Applied Science Energy Systems and Bachelor of Computer Applications. So this is the first in its series. From now onwards, we will have 1 or 2 sessions every month so that we will cover all the blocks of this particular course. In today's session, we will discuss about Unit 1 of Block 1, Computer Basics and PC Software. This particular course is very interesting course. Why? Because nowadays, literate is not a person who just know or else write or read a particular language. However, literate is in the sense nowadays it is taken as a computer literate. In our daily walk of life, there are various uses of computers. Right from morning we open our mobile phone till we sleep, we encounter many applications wherein which for each and every application computers are involved. So this course has 3 blocks for BCS-011 and BCS-111 students, and BEY-020 there are 4 blocks, but the course remains the same. However, the BEY-020 has one particular tutorial as the 4th block. So before we start, in today's fast-paced digital world, computers are an integral part. So if you go to railway reservation system to book a ticket, it involves computers. If you wish to browse the internet, once again we browse the internet through desktop, laptop or else through our mobile phone also. So this particular computers became a kind of integral part. Right from smartphones to smart homes, computers power the technology that drives the modern society. Understanding computers is not just a skill, but it became a kind of necessity that opens the door to numerous opportunities in various fields. You can name in any particular field where the computers are not used. Straight away the answer is no. So in each and every domain we are using the computers. In medical domain, aeronautics, in reservations, in college admissions, and there are various applications pertaining to each and every domain also. So let us try to define what is a computer. A computer is an electronic device that processes data. So for each and every, like this particular definition, you have to remember 3 or 4 terms. One is input, the other is the process, the third is the output, and the fourth is the storage. So these are the 4 terms one has to remember whenever we are defining a computer. So a computer takes input, processes it, stores the information in the storage, and provides output in a format that is useful to the user. So whatever the case may be, whatever the application that we talk about, all these 4 things are inculcated. So here you have to have the input. Once again, the input is being processed, stores the information, and provides the output in a format that is desirable. So this is the simple definition that we can give about the computer. Whether you are typing on a desktop using an ATM or even sending an image through an email, or else sending a message from your laptop, you are interacting with the computer. So there are certain things you input through your keyboard, the characters, or else the English language whenever you are writing the email, and then you frame the complete email, and then you send it through your system. So these systems are designed to perform a wide variety of tasks, from simple arithmetic to complex simulations that can predict weather or powerful in artificial intelligence applications. So before we go to learn these particular systems, we talk about the origin of the computers. So straight away, the computer is not born. However, there are several numerical or calculating devices which were its predecessors. We can call it as a predecessors. So nearly 5,000 years ago, the abacus was developed in China in 3000 BC. So this was the first calculation board, we can say, and the abacus may be considered as the first computer or calculator, and it has been used since ancient times by a number of civilizations for basic arithmetical calculations. So it has its roots, the calculating devices has its roots way back some 4,000 or 5,000 years ago. So you can see here, I had given one illustration of abacus, and this abacus is called as a counting machine or else a calculating tool for performing the arithmetic operations. So it was invented by Chinese abacus, and then this is used even today to teach small children how to count. So this abacus, you can see there are several pipes attached vertically, and then there are certain beads. So it was made up of wood or else even metal nowadays. So the Chinese abacus has a frame holding vertical wires, you can see, with 7 beads on each wire. The down part of the frame consists of 5 beads and the upper part consists of 2 beads, and there is a slight wooden separation, or else you can call it as a divider, you can say, and then it separates the top 2 beads from the bottom 5. So the arithmetic calculations are performed by manipulating the beads by using the principle of positional weight of beads on a rack. So this was the illustration of the abacus, and next we can talk about an interesting device called as Napier's bones. So John Napier was a mathematician who became famous for his invention of logarithms. So he invented a kind of mechanical device for the purpose of multiplication in 1617 AD, and the device was known as the Napier's bones. So his bones were set of 11 rods, side-by-side products and quotients of large numbers which can be obtained. The sticks, whatever those are placed vertically, are called as the bones because they were made up of bone of ivory. You can see here, this is the illustration of Napier bones, where in which it has a kind of 11 rods, you can see 1 to 9, and in between you have 2 times 1 and 0. So 11 rods are there over here. And this was the second interesting counting device that we can talk about. The third device that we can talk about is the slide rule, which was invented in 1624 AD. So this particular slide rule was invented by an English mathematician, Gunter, and we can call this particular device as the Gunter's rule also. So the slide rule appeared in various forms during the 17th century, and it consists of 2 movable rulers placed side by side. Even now in some of the museums, when you visit UK, you have these Gunter slide rules displayed over there also. So each ruler is marked off in such a way that the actual distances from the beginning of the ruler are proportional to the logarithms of the numbers printed on the ruler. So by sliding the rulers, one can quickly multiply or divide. So this was an interesting tool. I will show you the illustration also. I'll show you the diagram. So this was the Gunter scale that we are talking about. So this device is third in its place, in 1624 it was invented. Most of the surveyors, mechanics, craftsmen and retailers used these Gunter scales to make logarithmic and trigonometric calculations. So the fourth one that we can discuss here in its series is the Pascal's calculator. So Blaise Pascal was a French mathematician and one of the first modern scientists to develop a build calculator. He developed a machine at the age of 19 that was capable of adding and subtracting the numbers. So the machine was operated by dialing a series of wheels, gears and cylinders. So these machines, whatever we are talking about, this Pascal's calculator is, once again, it is not a digital device. However, we can call this one as a mechanical device. So it is having a series of wheels, gears and cylinders. So this is the Pascal's calculator. You can see here. So one cross section is on the left side and the other complete device is on the right side. So there is Leibniz multiplication and dividing machine. Like Pascal, Leibniz was 17th century scientist. The calculating machine invented by Leibniz is considered a technical marvel of its time and ranks among the most precious cultural treasures of the 17th century. So this is the Leibniz calculating machine, you can see. So all these devices, you can see these are all mechanical devices. So you can have you can see the gears, the cylinders and other kind of equipment, the turners, the rotators and other kinds of equipments, the frames. All these will be helping in calculating the numbers. So then this is the difference engine is the actual mechanical computer, not the electronic computer, you can say. Charles Babbage, in 1920, an English mathematician, started working on a difference engine. And after 10 years, he abandoned that machine. And once again, he started with another machine called as the analytical engine. So this particular differential engine or else the analytical engine are the first computers wherein which he introduced the concept of storing the program or else running a kind of instructions through punch cards and other kinds of things. And Charles Babbage is called as the father of the computer. So Babbage outlined the basic elements of a modern general purpose computer which was based on the method of finite differences. So he started with the difference engine. You can see it weighs 5 tons, 8,000 mechanical parts inside and is some 3.4 meters long. And this was completely steam powered. So this device was completely steam powered. However, after 10 years, he started with a different kind of device called as the differential engine. We will just have a look of the difference engine. This is the difference engine. You can see it is a room size engine, wherein which the actual concept of the computers has introduced over here. And the analytical engine, after 10 years when he started the difference engine, the analytical engine incorporated an arithmetic logic unit, control flow in the form of conditional branching and loops, and integrated memory. You can see in the analytical engine we are hearing the actual computer terminology like the arithmetic logic unit, the control flow, conditional branching, and integrated memory. So this is the first design for any general purpose computer, and that could be described in modern terms as Turing complete. So this is the analytical engine, and the right side person is the Charles Babbage, and he is also known as the father of the computer. So you can see here I had started giving the details about the contribution, year, inventor, and specialty. So analytical engine is the invention made by Charles Babbage, which is operated mechanically. And there are another two versions called as analytical engine version 1, analytical engine version 2 in 1991 and 92. Then comes the Turing machine in 1936, which was introduced by Alan Turing, a hypothetical machine with predefined rules. And then there is another computer which came into appearance in 1937. And actual Van Neumann architecture, which we will see the complete details of Van Neumann architecture in the next episode. In 1960, Van Neumann architecture actually designed a specialty called as single memory storage program architecture, wherein which it described how a program reproduced itself. So that was the actual concept, which is very much nearer to the present day computer science. And then in 1974, you can see Altair 8800 was the first PC invented by Henry Edward Roberts, wherein which it has a memory board and the interface board. Just like we have the keyboard and other kinds of things. It came, the Altair 8800 series came along with the memory board and as well as the interface board. So before going to the actual details of the computer, let us see what are the various generations wherein which the computers have been there as on present day. Straight away, this was not the design, whatever we are just looking in when you take the case of a desktop, simple desktop on our offices table, or else on the laptop that we are using today. However, it has passed several stages along with several circuitries or else main electronic components, and then today whatever we are seeing is with ultra VLSI design. So all the computers, when we talk about the generations of the computers, it falls under 5 generations. It started way back in 1940, and for every 10 years we take as one generation. The generation is not just we are counting it by 1 decade. However, there is a variation wherein which what kind of electronic component is used, what kind of programming languages were used those days, what was the speed, what was the size, what were the input and output devices used using the generations. So these are the parameters wherein which essentially plays the role when we talk about the generations of the computers. So in the first generation of the computer, from 1940 to 1950, the basic electronic component that was used in the system was the vacuum tube. And in the memory, coming to the main memory, magnetic drums and magnetic tapes were used during the first generation computers to store. And the programming languages was only the machine language. So the first generation computers were understanding only zeros and ones. That was the machine language. And the power, as you can see, it is the whole systems were like a big room size or else a building size, and generating much heat, and the speed was very, very, very slow. and very large in size. So there the input and output devices were manually done using the punched cards and the paper tapes. Examples here you can give are the ENIAC, that is electronic numerical integrator and computer. ADVAC is there, electronic discrete variable automatic computer. UNIVAC 1, universal automatic computer. IBM 650, IBM 701. So these were the first generation computers. And then those days only 100 different vacuum tube computers were available all over the world. So these were not like in lakhs or thousands in number. However, only 100 pieces were available those days. So this is the illustration that you can see. On the left side is the actual electronic component that we are talking about, that is the vacuum tube. On the right side you can see the ENIAC machine, that is electronic numerical integrator and the computer. So these were the first generation computer that is appearing along with the vacuum tubes as the main electronic component or the circuitry. When it comes to the second generation, main electronic component was the transistors. Memory was magnetic core or magnetic tape. Programming language is slightly improved, and people were using assembly language as the programming language. Power and size was comparatively less. Why? Because the electronic computer has electronic component is a transistor over there and has reduced the complete size of the system. Examples are IBM 1401, IBM 7090, 7094, and then the UNIVAC. So this was the details about the second generation computers, wherein which the main electronic component is the transistor. So this is the UNIVAC machine you can see on the right side or the lower down left side. And the transistor also you can see here, the transistor is placed over here, and hugely the computer size was reduced when you compared with the first generation computers. And the third generation computers were counted from 1960 to 1970. The main electronic component those days they were using is the integrated circuit. So many transistors were being integrated into a kind of one IC, and then the memory was large magnetic cores like magnetic tape, magnetic disc was used. Programming language you can see here, higher level programming languages like Fortran, formula translation, BASIC, Pascal, COBOL, C were introduced during 1960 and 1970. So size became very much smaller. Why? Because integrated circuits were used as the electronic component, and speed has improved a lot when compared to the first and second generation computers. The input and output devices are the magnetic tape, keyboard, monitor, and printer. And the examples, as you can see, IBM 360, 370, PDP-11, UNIVAC, or the UNIVAC, the model is 1108, comes under third generation computers. You can see this is the IC placed on the left side, integrated circuit, and then PDP-11 and the IBM 360 are placed over here. So these comes under the third generation computers. In the fourth generation computers, main electronic component is the very large scale integration component, or else the microprocessor you can say. The memory, semiconductor memories were introduced. RAM and ROM were introduced during this particular stage. And mostly from 1972 to present, whatever we are using are the very large scale integrator electronic components, or else ultra scale integration components. So these particular things comes under the fourth generation computers. So the programming languages are very much modern in nature, like Python, C# and other kinds of programming languages we are using right now. Size became very smaller, and then speed and computers, desktops and laptops became very much cheaper. And then input and output devices are keyboard, pointing devices, optical scanning, monitor, printer, etc. These are the input and output devices that we are using. Coming to the network, most of the computers we are using today are being networked. So in organizations, MNCs and other kinds of companies, most of the systems are not standalone. However, they are being networked, and then we are sharing the resources using the network. So examples are IBM PC Star 1000, Apple II, Apple Macintosh, whatever that we are using today. Then this is the very large scale integrator electronic chip that has been placed over here, and the IBM computer that we are using today. So in the fifth generation computers, main electronic component is the ultra large scale integration technology, and parallel processing methods are the main things that we are using in the fifth generation computers. The fifth generation computers is nothing but whatever we are doing right now. comes under the 5th generation computers. The main focus is being on the artificial intelligence. So there are natural language processing, machine learning, and then artificial intelligence, deep learning. So most of the things are being covered over here in present days. So when it comes to the power, it is consuming very less powers, and then speed is remarkably very high, and then size is portable, small in size. Input output devices are keyboard, monitor, mouse, trackpad. There are many innovative input devices that are appearing in today's systems, and then examples are desktops, laptops, tablets, smartphones, etc. So these are the Intel chip that is ultra VLSI design. So in this particular session we had covered unit 1 of block 1, computer basics and PC software. In the next session we will try to cover the introduction to computer systems and operating systems, wherein which we will discuss the Van Neumann architecture, the block diagram of the earlier computer, and what exactly is the operating systems, what are the functions of the operating systems in the next session. I hope you understood this particular session, which is the introductory session for this course, and then in the next sessions we will cover the rest of the topics. Thanks for your attention. Thank you.